Hello, in this video I'm going to show you a visual model that can be used to complete the square. Completing the square is an algebraic manipulation that is used when dealing with parabolas, that is, functions that create a shape that looks like an arch or like a U on the graph. And the reason that we do this process, that we complete the square, is because the two different versions of the equation of a graph tell you different information about the graph. And sometimes it's useful to have both of those forms in order to get all of the information possible. So this first form of the equation of a quadratic is called the standard form. And it tells you a few different things. The coefficient A tells you whether the graph is going to be opening up or opening down. And the value of C tells you where that curving shape is going to cross over the y-axis. So that's already telling you two different things about that shape. This other form here, which has, as you see, a square in it, it's got an x minus something squared, is called vertex form. Sometimes it's called general form, depending on your textbook or resource. So in Canada and much of the States, it's referred to as vertex form because that's telling you what it is that this particular form provides. It gives you additional information about the graph. It tells you the location of the vertex. And the vertex is, if it's an opening up like this little U shape here, the vertex is that lowest point or the minimum. If the shape of the graph is that it's opening down, like this arch, then the vertex is that maximum point. And if you're talking about a problem where you're solving for a minimum or a maximum, then the vertex form would be useful because it would help you to find that point. So I'm going to show you how to use a visual model to get from the standard form to the vertex form. It's an algebraic strategy that a lot of students have trouble with. And I find that this visual way of representing it can be helpful. So let's start with a quadratic that is in standard form, x squared minus 6x plus 11. So you can see the features of this, that it has a squared term, it has a linear term that's just in x, and it has a constant term of 11. So that's my c. That's where it's going to cross over the y-axis. No leading coefficient that I can see, which means the a value is actually 1. So my graph is opening up. And this particular parabola is going to have a minimum point. So now I'm going to do the completing the square to find where that minimum point is located. So the first step is to turn this x squared into a little square. And the dimensions of the square are not important. It's just representational. So I'm going to use a 2 by 2 square just to be efficient with my use of paper. Now I've got minus 6x as my middle term. So I'm going to take that minus 6x. I'm actually going to change color to remind myself that it's negative. I'm going to be using red for negative. And I'm going to split those into two equal pieces. So I'm going to have negative 3 x's on one side of this square that I just drew. And they're bar shapes like that. So there's my negative 3 there. And then another negative 3 on the bottom like that. So I've split those negative 6 into two groups of negative 3. And then what's left in this space to complete this square is, as you can see, a little square that contains 9 individual units. So from this 11 that I've got in my constant, I need 9 of them to complete the square. So I've got x squared minus 6x, and 9 is my square. And then what do I have left over from my 11 if I've taken 9 of them and put them in that square? I've got 2 left over. So all I've done in my expression here, the only difference between the first and the second form here is I've broken 11 into 9 and 2. And that brings us to this component. The first 3 terms that I've got here are a trinomial that is a perfect square that is represented in this diagram that I just drew. The dimensions of this square are x minus 3. So remember, these were negative 3 bars, and x minus 3. So that brings me to the vertex form of this particular example is going to be x minus 3 squared. That's our shape that we drew. And plus those 2 that did not get added to the square. All right, let's do another one. X squared plus 4x plus 8. Okay, step 1. Draw your little shape that represents x squared, x by x. Then look at your linear term, that's 4, so I'm going to divide that into 2 groups of 2. Everything on here is positive, so I'm going to keep everything in blue. So there's 1 bar, 2 bars, and then 1 bar, 2 bars, like that. And to complete that square, I would need to add 4 units in this bottom right-hand corner. Well, what I've got in my constant term is 8. So that means I'm going x squared plus 4x plus 4. And then what's left over of that 8 is another 4. And this first 3 terms of that expression are the square. So in vertex form, x squared plus 4x plus 4. Well, the dimension here is x plus 2. Down the left-hand side, also x plus 2. So this is x plus 2 squared. And I've got this plus 4 out the side. And one piece that I neglected to add up here at the top is that out of this vertex form, I can pick out the coordinates of the minimum in this case are 3, 2. And in this case, the coordinates of the vertex are negative 2, 4. Okay, another one. X squared minus 4x plus 3. Again, make your little 2 by 2. That represents the x squared term. The minus 4x is split into 2 equal groups. 1, 2. And 2. And I'm using color to just represent the negativity of that middle term here. And then I've got plus 3 in my constant term, but what I actually need is plus 4. So in here, to complete this square here, I would have had to take 4 from my constant term. Well, the problem is I don't have 4 in my constant term. So what happens if you take 4 away from 3? You'd be left with -1. So again, the only thing that's changed from the first equation that I was given and this expression that I've got here is that the constant term of 3 has been rewritten as 4 minus 1 because I needed a 4 to complete this trinomial as a square trinomial. So this piece is the trinomial, and rewrite it again in vertex form is going to be, well, this is x minus 2 times x minus 2. That's the square of x minus 2, and then minus 1. And you can look at the other two examples above and see if you can figure out what the vertex point would be for that one. All right, one more. X squared plus 8x plus 13. So starting with my x squared, the 8x is going to be divided into 2 equal pieces, and attach those bars onto the right. So 4 and 4. Like that. So that means that to complete the square, I would need to be adding 16 units, 4 by 4. But to take 16 from 13, it's going to put me at -3. So this is now, this square is equal to x squared plus 8x plus 16 minus 3. So the 16 minus 3 is equal to the 13, right? So these two constant values create that 13. And I did that in order to make 16 little units here that would be able to complete a trinomial that is a perfect square. And that then is rewritten as y equals, it's the square of x plus 4 that's the shape here, and then minus 3.